Hey guys, it's Dr. Brown here, and tonight we're working a Calculus 2 problem dealing with the integral of x tangent squared x dx. Whoa. So let's get after it. Okay, what's the tools we have? We have U sub, trig sub, integration by parts, partial fractions, power reduction, long division, completing the square, and I'm adding another one called Q, which is methods of quadratics. I ran across this the other day. I had forgotten it. So now maybe you don't need the acronyms. I do, so all I can share with you is what works for me. It may not work for you, but it allows me to organize myself. For example, this is my toolbox. This is what I can reach into and say, wow, how do I solve this problem? Well, I use the tools in my toolbox. U sub, well, maybe not. Trig sub, well, it's a thought, but I have this other term here. What do I do with that? Integration by parts. Hey, that has merit. Let's try that, okay? Integration by parts. So I like the old DI method. It allows me to organize myself. So, and you can use the old method if you want to. It's the exact same thing. It just doesn't allow you to organize yourself. So good luck keeping up with your minuses in that thing. Okay, so let's choose what we're going to differentiate. I like the X. So that works for me. That leaves me tangent squared x dx. Okay, if I take the derivative of x, it's 1, derivative of 1 is 0. That's one of the stops. If you know the DI method, there's 3 stops to that. If you take your derivative term you derive down to 0, stop, okay? Or as you integrate and you get everything together, if you see a row you can integrate readily, that's a stop. Or as you work along, this thing begins repeating itself. Once it repeats, that's a stop. Okay, so those are the 3 stops for the DI method. So what's the integral of tangent squared x dx? Well, let's just work it here. We have the integral of tangent squared x dx. And what is tangent squared? Tangent is sine over cosine. So this becomes the integral of sine squared over cosine squared. Okay, well, sine squared is 1 minus cosine squared. I'm going to work along the fault line here in my board. I have a crack. Okay, I have sine, which is 1 minus, sine squared is 1 minus cosine squared, x. Now, they're all over one term. It's all over cosine squared x. I'll just divide those into 2 fractions. 1 over cosine squared, 1 over cosine is secant. So we have the integral of secant squared x dx minus cosine squared over cosine squared is 1. So I'm just integrating on dx. So the derivative of tangent is secant squared. So the integral of secant squared is tangent x. So the integral of secant squared becomes tangent x. Integral of dx is x. All right, so putting here is tangent x minus x. Okay, take a snapshot. 3, 2, 1. Okay, clear out of space. All right, now then, I've got to integrate tangent x minus x. Now we know, you should know, or if you don't know, you will, okay? The integral of tangent x is minus natural log cosine x. But let's just work that out. Okay, so we have the integral of tangent x minus x dx. Okay, so I have the integral of sine x over cosine x dx minus the integral of x dx. Okay, let's let, hey, U sub, now I'm reaching in my toolbox. UTI, PPL, CQ. Okay, U, I'm going to let U equal cosine x. Let's work that here. U equals cosine x. Du equals minus sine x dx. Now I need to solve for this dx here. So I need to divide both sides by minus sine. And that equals dx. All right. Let's plug some things in here. I have the integral. I still have sine x over cosine x, which is u. Dx is du over minus, I'm going to put the minus out here, minus sine x. So those cancel. So I have minus integral of the derivative of a function over the function. Integral of du over u is natural log of u, but I have this negative. So negative natural log u, and u is what? Cosine x. Okay. So all of that becomes minus natural log cosine x minus, what's the integral of x dx? Okay, that's x to the first power, right? So we're going to increase it by 1 as 2, divide by that, so I have minus 1/2 x squared. So what do we end up with here? Minus natural log cosine x minus 1/2 x squared. Okay, snapshot, 3, 2, 1. Yo, away we go. Now then, we're almost ready to do something here. Okay, so this integral equals positive times positive times positive is a positive, so that's x natural log, it's x times tangent x minus x times tangent x minus x minus times positive is a positive, or negative times positive is negative times negative. We'll do these one at a time here. Negative times negative is a positive, so plus natural log cosine x. Negative times negative is positive 1/2 x squared. So now I'm going to distribute the x inside of this guy here. So x times tangent x gives me x tangent x minus x times x, x squared, plus natural log cosine x plus 1/2 x squared. I can combine some terms here. Have a minus x squared and plus 1/2 an x squared. Well, this is minus 2 over 2 plus 1 over 2 gives me minus 1/2 x squared. So I end up with x tangent x minus 1/2 x squared plus natural log cosine x plus c. And that, my friend, is the integral of x tangent squared x dx. Hopefully you get familiar with the DI method. Now we could have said, okay, I'll pick out a u, I'll pick out a dv, I'll take the derivative of this, end up with du, I'd take the integral of that, end up with v. Isn't that exactly what we just did? but you'll end up doing this twice. So you'll end up with uv minus the integral of v du, but you'll have to do it again, and this will be minus all of this uv minus v du again, minus a minus plus. You've got to do these same things, but it's not as obvious to me. Maybe it works for you, but this just allows you to organize it. It's the same exact thing in an organized manner. So look for black pen, red pen. Look at his site. The guy is phenomenal. And look for the DI method with him, or look up tabular method. But I would think black pen, red pen is the best guy in YouTube to define this for you. He has a lot of material there. Okay. Why are we doing this? Hey, together we're trying to build a better tomorrow, and do that how? Do that through math. Keep studying, guys. That's all for this time. Talk to you soon. Bye.